discuss some of the questions which I have given as part of the assignment to solve the same, right? Yes, I just quickly read out some of the short questions and then I want answers from your side. If you can rather, it's well and good. Otherwise, I'll give you right. What programming now has dominated scientific computing over the past 20 years is Fortran and now, of course, C as well has been taken mostly into it. Right? In business applications, second question is COBA, and then now we got many of such ERP and other kind of tools, mainframes, and all kind of things available for doing the same. But programming language point of view, if you see, the first programming language for business application is the COBA language. Right? What programming language has dominated artificial intelligence over the past 40 years? Right? We have Prolog, and we have Lisp, these kind of languages, and now we got Python and R and many of the tools available for artificial intelligence in the current scenario. In what language Unix is written? Can anyone of you please? Fourth question. Unix is written in C language, right? Unix, of course, a lot more compared to the previous operating. It's a time sharing operating system. It is a resource sharing operating system. It is a multitask operating system. You can say, right? A lot of features like process management, file management, disk management, IO management, and bootstrap loader program in the lower part of the memory, right? So this bootstrap loader program, which is available in ROM, read-only memory. So when you switch on the system, what happens? The entire hardware will make the program counter. Program counter is a register, processor register, which will give the address of the instruction to be executed, right? So CPU will execute the instructions of which address is specified by the program counter register. So what program counter register does when you switch on the system, it will hold the address of the first instruction of the bootstrap loader program. So it means CPU is going to execute what? Bootstrap loader program instructions, right? Because the first instruction address is being held by the program counter register when you switch on the system. So the instructions available in the program bootstrap loader program right from the first are executed. So when they are being executed, what is the outcome that you get? The bootstrap loader program instruction that you have is to load the operating system program which are available in the hard drive into the your system memory in your RAM, right? Preliminary memory. Okay, so there is a part of the RAM for which operating system programs space is reserved. So all these operating system programs are going to be loaded into that respective space. Okay, so once the operating system programs get loaded, right, ready to provide the services, right? The services which are running in the background, we call it as daemon process, right? Or daemon process, or whatever you call it, DAEMON. So the processes that are running in the background are said to be the daemon processes, right? So all the operating system services are going to be rather provided with the help of these daemon processes once the operating system get loaded, right? So that is possible by this bootstrap loader program being executed, and this is the first program which will be executed over the system when you switch on the system. What is orthogonality? Orthogonality is something like the features of the programming language are perpendicular to each other. For example, if you see in C programming language, you have structures and arrays. These features are orthogonal to each other. How? Arrays are a collection of homogeneous elements, right? Structure is a collection of heterogeneous elements. So they are opposite to each other, right? So from the characteristic point of view. So when the programming language is offering such kind of features, you say. So anyway, these are some of the short questions, and I think most of it probably 2-3 line questions. I'll focus on long answer questions first, okay? From the problematic point of view, we'll see first, right? There's some theoretical questions you can see at the beginning in the long. For these questions, you can rather go through the videos. In videos, it is clearly explained. Explain the reasons for studying concept programming. Discuss the language evaluation criteria. Analyze and explain the influences on language design. Describe the implementation methods for programming language. Explain both compiled and interpreted implementation methods with the help of neat diagram. These are all there as part of the videos. You just go through it. Write a program in C language to count the number of values which are more than the average of given input values. Okay, all of you, please, write this program and submit me in this. Will you be able to access this? Yes. So the question is, write the answer in the next sheet also. Okay, all of you start doing it. If you have finished, you can rather take the help of the Stamboard and you can write on the same by writing your roll number and name on the top right corner and then start writing the program. Okay, otherwise you can share the same through chat box. Okay, we on to the next question. These are some of the programs which I'm giving you as an assignment. So you just go through this because you are already acquainted with C and C++ and Java. Write a program in C language to count the number of values which are, this is the first one. Write a program in C language to find the entire number is prime or not. Write a program in C language to print the weekday. Okay. So these are some of them. You just work out as your assignments and submit me. Fine. Go with the Jamboard or chat box. Next, coming to grammar. I'll focus on the grammar, right? Okay, using the grammar, show a parse tree for the following statement is asked. Okay. So here the grammar is given. The grammar is given to us. R A into T. Again, you have vertical bar. It's said to be R. So R enclosed parenthesis. A is in enclosed parenthesis. Okay. Then you have again R followed by T. Okay. And then T is defined to be A or B or C. So this is the grammar given. Right. So in this grammar, you can see using this grammar, he asked us to construct the parse tree. What is that he is asking me to do? He is asking us to construct a parse tree for the following statement. So these are the two statements given: A equal to B plus C plus A equal to within parentheses A plus B to C. Per one after the other. Will I'm not able to copy it. No, I can. Right. Yeah. So let us take this question here. Okay, so this was a question. Yeah. So this was a question. What is the question? Using the grammar, show a parse tree for the following statement. So BNF grammar is given to us. This is the BNF grammar, and this is the statement. Let us take the first statement. Okay, to consider the parse tree. So the statement is A equal to exploring the tree. So here the root node is the statement. So the statement, if you see, assign is the statement, right? So assign is the root here. Assign is defines to be A equal to A. So A equal to A is written. Next is what? Next is I want this particular statement rather, right? I want this particular statement to be derived with the help of the parse tree. So now in place of this A, okay, which is a non-terminal, considered to be an assignment statement or expression, which I need to explore it as terminal A. So in order to get terminal A is derived from T. So first I need to have t in place of a, and I can see that t is derived from a. So it means t has to be, sorry, a has to be defined a has to be defined to be t here, because you can see definitions for a. There are multiple definitions for a. You have one definition for a is defined to be a plus t, you said. Another definition is a into t, you said. And another definition given is a enclosed in parentheses. And another definition given is a defines to be t. So I am taking the last definition of a here in case of this a in order to get a. Okay. So now on the right hand side, you can see this expression a has to be explored, and then I need to get b plus c plus a. So in order to get b plus c plus a, by exploring this, what kind of definition I need to take for a among the definitions that are available over here. So you can see that I can go here with, in order to get, because both the operations are placed, so I can get now this a. In order to get b plus c plus a on the right hand side of the assignment, operator, I can see that a plus t is a plus a. The equation is a plus b plus, sorry, a equal to b plus c plus a. Okay. So now in order to derive this particular statement using this grammar, okay, I am starting with root assign, and assign is defined to be a equal to a. So a equal to a, then this a is further defined to be t. Okay, and this a is further defined to be a plus t, sorry, a plus t, getting the point. And then this a can be further defined to be again a plus t. Okay, and this t is defined to be a. Okay, and then this f is further defined to be t, and then this t further derives to be b, because you can have multiple definitions for t. You can take either of them. I'm taking b here in this case, and in case of this, in order to get c here, I'll be taking c. In order to get a here in this equation, or derive the same, in place of this t, I'm taking a. Okay, so now I can see my parse tree is constructed for this particular statement using this particular grammar in a very unique manner. Okay, so first definition that I took is, of course, starting from the root or the assignment statement. So assign is my root here. So assign defines to be a equal to a. I said, then the left hand side, okay, that is a, which is said to be a non-terminal, or I can say here in this case expression, fine, or a simple variable rather, right? So basically non-terminals can be further expanded to be either expressions or variables, or of course to be terminals rather, right? Fine. So the non-terminal a is derives to be here t. Okay, since I have to get this particular statement to be derived using the parse tree. So a is derives to be t, then t is derives to be a. So I got a here, a equal to, I got a equal. Then on the right hand side, you can see a is defined to be a plus t. I have taken the first definition. Okay, then again this t is further derived to be a here, because I have to get a here. But the left hand side, if you see, I can further expand it with another definition, but I'll go with the same definition since I need plus operation only. So I have derived a with a plus t, and then a is further defined to be t, and then t further defines to be b. So I can say b plus c plus A here, right? So I got the statement A equal to B plus C plus A is derived using this particular grammar, right? So now we'll try to understand this grammar, right? How this grammar and what are the elements in this grammar, what type of grammar this is called to be, and is this grammar is unambiguous, is it correct or not? We'll probably discuss all these kind of things now looking at this grammar. Okay, so now if you look at this grammar, assignment statement, for assignment statement given, basically context free grammar CFG, is being defined by, as I said, either BNF or CNF, right? So BNF is widely being used, which is being developed by John Bakers. So here you can see in the assignment statement. Assignment statement, you can see there are two lines and then followed by the greater than symbol, right? Okay, so assign defines to be A equal to A. Okay, so this kind of statement is said to be a recursive statement when you have LHS available on the RHS part, right? Okay, so this is said to be the recursive grammar. Recursive grammar. Now this A is further defines to be A plus T or A into T or A enclosed in parenthesis or just T. Okay, so where T is again a non-terminal which has been further defined to be either A or B or C. So here you can see that the LHS A in this particular statement, the LHS A is available on the RHS part. Okay, this is the RHS part, this is the LHS part. Okay, this is RHS part, right? Again, you can see the LHS part is available on the RHS part. Okay, so this grammar is also a recursive grammar. This is also a recursive grammar. Okay, this statement is also defined with the recursive grammar. But then, if you see on the right hand side, you have an operation plus, and this operation carrying two operands, left and right operand. Okay, and the LHS part is available on the LHS of the RHS part, right? Okay, so when the LHS part is available on the LHS of the RHS, we say this kind of grammar is said to be the left recursive grammar. Okay, left recursive grammar. This is said to be left recursive grammar. Okay, so you can see the next statement again, where the second definition given for A also is defined with the help of left recursive grammar only, because the recursive grammar, because the left side, the LHS part is available on the LHS of the RHS. So this is said to be the left recursive grammar. So left recursive grammars are solved using the rightmost derivation. Using the rightmost derivation. Okay. So derivation in the sense, I'll derive the same instead of parse tree. I can derive it with the help of simple expressive statements, which is said to be the rightmost derivation statements, right? So the same grammar, I'm here deriving it with the rightmost derivation, right? So how do I do that for this particular statement to derive rather, right? I say assign equal to this T. I can explore it with definition B plus C, and now this T is derived to be A. So I get A plus B plus C. So this is said to be the rightmost derivation, right? Rightmost derivation, right, of this particular statement, A plus B plus C, right? So this is how in statement wise you derive a particular statement using the grammar, right? I said this is a rightmost derivation because you can see the terminals you can find being substituted from the right onwards. Yes or no? You can see first you got the C here, that is from the right onwards you got the terminals, and the terminals are being substituted in order to get that particular statement. This A is further defines to be a T, and then T defines to be here A, so A equal to, you say, right? Anyway, so you can see the terminals are being substituted from the right onwards, so that's why we say it is a rightmost derivation. So left recursive grammars are solved using the rightmost derivations. Okay. So if a grammar is given and you are asked to construct a parse tree for the statement, first you derive it like this and then go for the construction of parse tree, then you don't do any kind of mistake. Or you can directly go for constructing the parse tree as well, as I have shown you, right? Starting by the root, which is said to be the assignment statement itself, and then when you start exploring the non-terminals, you have to ensure that the statement that is being given should be derived, okay, in the order in which it was given. So if you can probably ensure that, then automatically you get the parse tree. Fine. But another way of constructing the parse tree is first you derive the statement. Okay, derive the statement like this. Then you can probably construct the parse tree. Once the derivation is available with me, I can just directly go away to start constructing the parse tree. Like how assign A equal to A I said, then here A I said in place of assign, then say in place of this A I said A plus T, right? In place of this A plus T I said, then in place of this A T, and then A, of course, right? But in place of this A again is further substituted with A plus T, you can see here, right? And then this T is substituted with I need to get A here rather, right? So I think it is A here. B, sorry, B plus C plus A, no, right? Sorry, this is A. So A, and then I should get C here. Then I should get B here, right? So B plus C plus A. Okay. So if I have the statement being derived using the grammar, then constructing the parse tree is quite easy. But if you can directly construct the parse tree, that is all fine for you, right? However you want, you can do it. Is it clear to all of you how to derive the statement when the grammar is given and how to construct the parse tree, right?
Sir, what are terminals and non-terminals?
Yeah, so terminals generally which cannot be further explored, like for example A, B, C, which are not enclosed in tags. The elements which are enclosed in tags are said to be non-terminals. Okay, non-terminal in the sense they can be further explored, right? But the elements which are not enclosed in terminals, like A, B, C, they are not enclosed in terminal tags rather, right? A, B, C are not enclosed in tags. So these are said to be the terminals, right? And these are said to be the non-terminals. So in grammar, generally you will have only two elements, two type of elements. You will have either terminals or you have non-terminals. Fine. How do you identify that whether it is a terminal or a non-terminal? When an element is enclosed in tags, right? This is tag, right? So if it is enclosed in tag, you say it is a non-terminal. If it is not enclosed, then you say it is a terminal, right? So terminal is generally available at the leaf because they cannot be further expanded, right? Leaves are the one at the end of your tree you find, from where you don't have any other branches or any other exploration. So terminals are those which are available at the end, or which cannot be further explored, or which are the atomic unit of the grammar. The other way around I can say that, right? So this is how the grammar is defined. If you have a grammar, how to identify the grammar, what are the elements of the grammar. As I said, there could be two elements, one is terminal and non-terminal, and there could be two type of grammars. You find left recursive grammar or right recursive grammar, right? When do you say it is a left recursive? When you find the LHS part on the LHS of the expression, you say it is a left recursive. If the LHS is available on the right RHS of the RHS, then you say it is a right recursive grammar. Left recursive grammars are derived using the rightmost derivations. Right recursive grammars are derived using the leftmost derivations. Okay. And once you derive the statement, these are the statement that is, say, for example, you are given and asked to derive the same using the grammar. Then first you derive like this. These are the steps how you are going to derive it. Once you derive, then you can construct the parse. This is how you can construct the parse tree. Okay, is it clear to all of you? What is the second statement you have here is a equal to within parenthesis a plus b into c. Okay, let us now first derive and then construct the parse tree. Fine, this is what the right procedure is, right? Okay, so first we will derive this. How will we derive? We'll start with the start symbol. This assign is said to be the start symbol. Okay, assign derives to be a equal to a. Then in place of this a, what do I want? I want a. In order to get a, I should first derive a as t. So a should be derived to be t. Then t can be further divided to be a. So I'm taking here. I'll just move here. I'll start from here. Okay. And you say that assignment statement now here derives to be a equal to a. In place of this a, I should get a. So I'm deriving a to be t here. I have multiple definition for a. I can go with either of the definition. Vertical bar is separating all these multiple definitions and giving a meaning of r here. So a is defined to be either a plus t or a into t or a enclosed in parentheses or t. So I am here deriving a to be t on the right hand side. Now a, this a again here I can rather define with any of the definition, but which definition I should go in order to get that particular respective statement to be derived? Can any one of you tell?
A into T.
Yes, a into t. So I'll go with this definition. So now this a and this t to be derived to be here. Now to get a here, I say a here, and then a. A is now further, which one? Which one should I go with? Here with this definition at this stage. What my point? So here a is further derived to be a enclosed in parentheses. What my point? And now this t is derived to be what? In order to get this statement, I need to have c here. So t is derived to be c here. Now within this parenthesis, I am having a again. This a is now derived to be with what definition? In order to get a plus b, I should go with the first definition. So it means I should go with a plus t, rather, right? Into c I have. Then this a has to be derived to be t here, and this t has to be derived to be b here. Okay, fine. And then this t has to be derived to be a in order to get a here. So this a plus b into c. Got the point? So this is how I derive, right? Got the point? So we have derived this statement using this grammar, and we could able to derive it, right? So the grammar given is correct. Now you want to construct the parse tree for the same. If you have statement derived, then constructing parse tree is quite easy for you. You start with start symbol as root, assign a equal to a, then this a this a will be derived to be t, and this a is derived to be what, a into d. I have the statements now. I can directly straight away go with the statement that I have used to explore the same. Okay, and just substituting, that's it. T has to be substituted with a, and this a has to be substituted with you know uh, open parenthesis a and close parenthesis. Then this t has to be substituted with c. Then t is derived to be c. Then again you have this a is further explored to be a plus t. You can see a plus t. Then you have a is derived to be t here. Then this t is derived to be b here. Then this t is derived to be a here. Okay, that's it. So I got my parse tree constructed. A equal to, within parenthesis, this is all within parenthesis rather, right? Within parenthesis you have a plus b close parenthesis into c. So this is how you construct the parse tree. So if the question is asked to construct the parse tree, I always suggest you to first derive the statement like this, okay, and then go for the construction. You never do the mistake, right? Compulsorily get the tree in the appropriate one rather, right? And this kind of definition is said to be what? For all left recursive grammars, you will be using rightmost derivation. This is a rightmost derivation at the point. For the right recursive grammars, you will be using leftmost derivations. Okay, so this is clear, I think, for all of you. Shall we move on to the next question? Is it clear now how the construction of parse tree you can do, and the derivation of the same if the statement is given?
Yes, sir. It's sir in a plus t here, sir. Last but second one. Should we include the braces here again?
Yeah, braces will be carried like that.
No, sir. Here in the diagram,
No
parse tree.
diagram. No, no. You have said no. This open parenthesis, and only this thing is being explored rather, right?
Okay,
So
sir.
this whole is in parenthesis only. So when you read, how do you read a equal to? Then you have open parenthesis, right? Open parenthesis. Then this whole is in the same, right?
Yes, sir.
Yeah, that is a plus b. Then you say close parenthesis. Then you say into. Then you say c. Okay. Okay.
Yes, sir. Cleared. Yes, sir. Cleared.
Yes. So this is how you're going to represent or construct the parse tree. So the other way around, I can say parse tree is a pictorial representation of the derivation. If the derivation is correct, your parse tree will be definitely correct. Here, the next question is 12th question. Prove the following grammar is ambiguous. Last class I have discussed that what is ambiguous. Grammar must be unambiguous. If the grammar is ambiguous, it is not correct, right? What do you mean by ambiguous? When you can able to construct more than one parse tree for the same statement using a grammar, then that grammar is said to be ambiguous. So here, let us take this. Shall I use the same otherwise, because anyway I am just overwriting. So I'll take one statement. How do I prove that the grammar is ambiguous? By ensuring that I am able to construct two parse trees for a single statement. Okay, using that grammar, then I say it is ambiguous. But then, what is the way in which you can be able to easily identify that the grammar is ambiguous? Yes, I will be telling you that, right? Just look at this grammar. The statement is derived to be A, he said, and A is defined to be A plus A. See, this grammar is said to be recursive grammar. Yes or no? Well, because you have LHS part available on the RHS. Okay. So when LHS part is available on the RHS, you say it is a recursive grammar. But then this is, you know, two-way recursive grammar. Okay, this is two-way recursive because you can see the LHS part is available on the LHS and RHS on both the parts of the operation. What the point? When you have the LHS available on LHS and RHS of the operation, then this grammar definitely leads to ambiguous. Okay, because when you have the LHS on the LHS of the expression, you say it is a left recursive. When it is available on the RHS, you say it is a right recursive. But this grammar is both left and right recursive. This grammar is both left and right recursive. When you have left recursive grammar, you can derive the statement using rightmost derivation, right? When you have left recursive grammar, you can derive it using rightmost derivation. Yes or no?
Yes, sir.
Yeah, rightmost derivation. So the grammar is left recursive. You will get one derivation using rightmost. That's fine. But the grammar is right recursive also, right? This is right recursive also. It means you can derive the statement using leftmost derivation as well. Got the point? So it means I will get two derivations. For a statement, I can get two derivations. So using rightmost derivation, I can construct one parse tree. Using leftmost derivation, I can construct another parse tree. Other point. It means I may have more than one parse tree for a given statement if the grammar is like this. Okay. In that situation, what happens? The compiler will be in a confusion in order to go with which particular parse tree in order to evaluate, because after the syntax analysis is done in the compilation part, the system will be given the parse tree. So if there are multiple parse trees, which parse tree should be given it for the implementation? The compiler will be in a confusion. Then the execution does not happen. It will be in ambiguity. Ambiguity means no clarity, right? There is no clarity now. There is no clarity at the compiler. So what parse tree I should give it to the system? Then what happens? Execution does not happen. So this is what the ambiguous grammar. So grammar should be unambiguous. Only then execution can be possible. So in an unambiguous grammar, you will be able to construct only one parse tree. When do you say grammar is unambiguous? When you can be able to construct a single parse tree for any given statement using the grammar, then that grammar is said to be unambiguous. And the grammar must be unambiguous, not ambiguous. Other part. Fine. Now let us take one step. Okay, let us look at this derivation here. I've taken one statement a plus b plus c. Okay. Let us take with assignment also either. You want to take a, let us say a equal to a plus b plus c. Which we can take like this also. So let us start with the start symbol. S derives to be a. Then okay, then you have a. For S we don't have, so I don't think this grammar will support this kind of statements. I'll take the previous statement itself. I'll take the previous statement. B plus C, right? A plus B plus C. Now let us look at this. A plus B plus C, okay? A derives to be here a plus a. So now here you can see a is derived, this a is derived to be a plus a, and then I can derive either this a first or I can derive this a first, right? If I derive this a first with the recursive definition, then I'll get one tree. If I derive this a with the recursive definition, I get another tree, okay? So here you can see I'll get here, let us say for example, if I am deriving this a with the recursive definition, then this a is derives to be a plus a, and this a is derives to be a id here, and then you can see this a is derived to be id plus id plus id. In place of id I take here c, then I say here a, and then b, a plus b plus c. This is one definition. So can you tell me which kind of derivation I have used here? Yes, which one I have expanded here with the recursive definition, whether it is LHS or RHS? LHS part. It means
LHS.
this kind of definition is said to be what? Rightmost derivation. This is said to be rightmost derivation. Okay, I can derive the same by expanding, that is said to be leftmost derivation. Let us look at the same a to be expanded with the recursive definition. I am deriving the right one. Okay, I am using right recursive grammar. Here I have used what? Left recursive grammar at the point. So if I am using left recursive grammar, then I say it is said to be the rightmost derivation. If I am using right recursive grammar, then it is said to be leftmost derivation. So now you can see here, this a will be substituted or derived to be id, and this is derived to be this. Here I am applying the right recursive grammar. So this will be a plus a. Then in place of this id, I'll get what? I, and in place of this a, I'll be getting id, and this a is derived to be id, And in the next statement, A plus this ID is substituted with B, this ID is derived to be C. I got, of course, the same statement being derived in two fashions, right? Right. Either by expanding the left recursive grammar or by expanding the right recursive grammar. Okay. So when I use left recursive grammar, I say it is rightmost derivation. When I use right recursive grammar, I say leftmost derivation. If I construct the parse tree, you see the difference. Construct the parse tree for this. How do you get the parse tree for this? You'll get two different parse trees, right? Let me construct this. S defines to be A. Then A is derived to be A plus A here. And this A is being applied with the left recursive grammar. So it is derived to be A plus A, and this A is derived to be ID here, and this A is derived to be ID, this A is derived to be ID, C, this is A, this is B, right? This is one parse tree, right? So using rightmost derivation, I got one parse tree. You can see A plus B plus C. Got it? And now let us look at this, right? And construct the parse tree for the same. S derives to be A. Here we are applying right recursive grammar. A is derived to be A plus A. Okay, and applying the right recursion here. And this is derived to be ID. This is applied with right recursion. A plus A, and this is substituted with A, and this is substituted with ID, this is substituted with B, substituted with ID, this is substituted with C. Now tell me, are they same? These two trees are different, they are not same. You can see here S is derived to be A derives to be A plus A, and A derives to be A plus A, and A derives to be ID and then A. And here you can see A is derived to be ID and then derived to be B, A is derived to be ID and C. But here you can see the tree is different, the structure is different, the mirror image of the same you can see rather, right? But they're not same. S derives to be A derives to be A derives to be ID and A. Whereas here in the left hand side, you can see the leftmost subtree, if you look at the leftmost subtree is going with AAIDA, but whereas here it is going with AAIDA, right? Here you got 3 A's and then ID followed by A. Here you got 2 A's. It means are the same? No, these two are not equal, right? It means they are two different, right? They are not equal means they are different. It means here using this particular grammar, I am able to construct two parse trees. Okay, so when you can be able to construct, more than one parse tree for a given statement using any grammar, then that grammar is said to be ambiguous. Right. So if the question is asked like this, prove the following grammar is ambiguous, you have to take one statement and then derive it using leftmost derivation and rightmost derivation, construct the trees, correspondingly, then show them that, more than one parse tree is being constructed for the same statement. So the grammar is not ambiguous. This is how you are going to. This is one of the important questions which is being generally asked in the external. Okay, I think I have this is clear to all of you. If any doubts, please raise. Is it clear to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Yes. So, shall I move on to the next question, or you want to take your lunch? If you allow me, I'll take one more question and then finish. What will you say? Is that okay? Shall I carry for 10 more minutes? Now it is 1:30. Yes, not responding. Okay. If you want me to stop, I'll stop it here, right?